Are you ready for me?
Dean Wesson, go ahead.
So welcome everyone. In case you don't know, I'm Rose Wesson and I'm scrolling down to the end of this presentation just to start out here. I'm Rose Wesson, Associate Provost for Research. Thank you for joining us today for this last session for the College-Wide Research Vision Initiatives. These are the final team presentations. What I want to note here on the last slide, and I'll say it again at the end of the session, is that we're asking the CRC to rate all 8 presentations by the close of business on the 31st. Well, I guess the 31st is not a business day, it's a Sunday. But by 11:59 p.m. on July 31st, we would like to have your score sheets by then, and we will collate them and compile them and make sure everyone's aware of the total scores. If there's no convergence, I mean, if there's not one team that seems to be stand out above the others, we'll have to discuss the process. We'll do that offline. But what I will say here is that the final review and selection will take place by August 31st. And the announcement of the award, the target date is September 1st. So if the CRC members at the conclusion of these presentations, if you can stay on for about 5 minutes or so, we'll continue this discussion. But what I'd like to do now is introduce the first team to present so that we stay on schedule. And our first team will be Team 5. And I think, Terry, you're the presenter for Team 5.
I am.
I'm going to turn it over to you, just so that everyone knows I will be advancing the slides. And if we, as Alan had said, if we have trouble with our 20 minutes, we will let everyone know. And the other thing I was supposed to say, Alan told me to say, was mute. If you're not the presenter, we ask that everyone mute themselves. So Terry, the floor is yours.
Well, good afternoon, Rosemary, and thank you all for taking the time to listen to our team's presentation of the Beloved Community Project. I believe I know many of you on this call, but I'll begin by introducing myself. My name is Terry Watson. I am an Associate Professor of Educational Leadership in the School of Education at the City College of New York. I joined the college in the fall of 2012, and during my interview with Dr. Doris Cintron, she was the interim dean for the School of Education at the time, she asked me why did I want to join the faculty of CCNY, and at this point, I was actually already on a faculty line at Florida Atlantic University in Florida, Boca Raton, Florida, and I had a pretty decent career, done some great things, but more importantly, I wanted to do even greater things in my home. So I simply said, Harlem is home. I consider CCNY part of my community, and I'd like to be a part of it in a real and meaningful way. So for those of you who don't know, I am from Harlem. I was actually born in Harlem, and I grew up in Lionel Hampton houses right along St. Nicholas Avenue. And I come from this community, and to be clear, I love Harlem, I love its people, I love us. So thank you. And this project, in many ways, is a love letter to Harlem. Next slide, please. So when thinking about this project, I asked some friends and colleagues to join me on this initiative. And one of them was Billy Council. Billy Council is listed as a non-teaching adjunct here, but he's also a really good friend of mine. He's a Harlem native, a small business leader. He's a mentor and a community advocate, along with my dean, Edwin Lamb Boy. Great guy, really happy he is our new dean and working with him, doing some really great things moving forward. But I also met and really have grown quite fond of Dr. Susan Perkins. As you know, she is the Dean of Science, and she specializes in infectious disease, and she has extensive experience communicating topics related to health to a wide array of public audiences. And I also asked another dear friend, Noel Menyendo, to join us. And he was really crucial to this because he has extensive experience with grassroots initiatives and aimed at advancing health equity. And importantly, he is a former Deputy Equity Officer of the COVID-19 response team. So knowing I had these great friends and colleagues at my disposal, I knew that we could move forward with the Beloved Community Project at the City College of New York. Next slide, please. So when thinking about the beloved community, people often think of Dr. Martin Luther King's concept of a beloved community, and they're not wrong. In fact, this concept is well known. And in short, it is a global vision wherein everyone is cared for. It's a community that is absent of poverty, hunger, and hate. Again, it's global, and it was inspired by a 20th century theologian and philosopher by the name of Josiah Royce. Josiah Royce characterized the beloved community as a divine space and place filled with people committed to doing the highest good for the greatest people in the common good. So in short, and I'm gonna say this a little, I hope more succinct, the beloved community is a space and place wherein the highest good is achieved as well as the common good. Now this may seem foreign to some, but this concept for the past few years have been really heavily weighing in on my heart and mind, especially as we are still in a pandemic. But a few years ago, when we were in the throes of it, when Harlem was really exacerbated with due to this pandemic, using and based on already limited resources, I wondered what could I do, not only as a faculty member here at City College, but also as a member of this beloved community. I wondered how I could really do the highest good, as well as the common good for the greatest number of people. And so I've been thinking, again, for the last 2 to 3 years about just what is a beloved community and how can I be a part of it? More importantly, how can I be a part of it here at the City College of New York? And this, I've been working on it, so that we're clear. I've been working on some aspect of this project, be it in conversation, be it during my role as a distinguished visiting scholar a few years ago at the University of Buffalo. But I've really spent a lot of time thinking about just what is a beloved community. And this project is a part of that, but it's part of a bigger project. But no, it's really consumed a lot of my time and talent. Next slide, please. So a lot of you are probably thinking, well, this doesn't really sound like an academic problem, and how indeed is this research? Well, you're kind of right. But, and I often use this quote by Cornel West to help people kind of explain what it is that I do. As you know, I'm a professor of educational leadership, and Cornel West has this, watching a lecture, and he said, leadership is service, and you can't serve the people if you don't love the people. So I wondered, what could I do in my work that could make my love for the people clear? And so this project is embedded in leadership, as well as service, and most importantly, in love. And as you know, the City College of New York was founded in 1847 and is one of the nation's greatest democratic experiments. It was intended to serve, and I'm quoting Dr. Horace Webster here, it was intended to serve the children of the people and the children of the whole people. And that really meant a lot to me, because this project, in many ways, it simply serves the people. More specifically, it serves the people of Harlem. And as you know, we are part of Harlem. So this is really for us. This project is reciprocal in nature. It's for us and is by us. And it's because we love us, because we love Harlem. So know that this research, in a nutshell, it simply combines the talented faculty in the School of Education, the Division of Science, and the CUNY School of Medicine, along with Harlem's residents, to address many of the problems that were exacerbated as we are still in the throes of the COVID-19 pandemic. So I simply wondered, how could we make this project public facing so that we are doing the greatest good for the people of Harlem? Next slide. What I found is that too often researchers, myself included, we go into communities, particularly communities of color in marginalized spaces, and we come in with a solution instead of working with the people to achieve the highest good, the common good. So this project, in many ways, complements the many of the good work that we already do, but we call it service. But I believe that our service and our work is one and the same. So this project uses a community-based participatory research lens that I really explain in depth in the proposal and the white paper. So if you have a moment, please have a look at that. But what this simply does is simply gives the people in Harlem access to us, to our talents and our resources and our time. And that's important to me as a member of this community and as a member of the faculty. Next slide, please. So this, in the next few slides, will explain CBR using a series of models. So I'm going to give you an opportunity to kind of have a look at that if you haven't already done so. I'm going to pause here, sip some water, and catch my breath. If we were in class now, I'd ask for questions, but I know this first 20 minutes is all on me. So next slide, please. This is CBPR. This is what it looks like as a conceptual model. So in this project, what we plan on doing differently, if you will, is that in light of the ongoing pandemic, we will work with Harlemites to produce workshops, programs, and events that complements and affirms the community's distinct culture and multitude of identities as we collectively endeavor to create a healthier Harlem. So it's for Harlem, it's based in Harlem, and it partners us with the community and other community-based organizations to address the needs of the people. But it's not just us addressing their needs, it's working with them to find a way north, to find a way out of this pandemic, to find a way to address their concerns. But instead of us, as many times as faculty and researchers, being the sage on the stage, we will actually partner with community members and CBOs to find out what worked for them. How can we complement the good work that already is happening in communities of color to just reach more people and to be more effective with both an E and an A. The outcomes, again, will be monthly workshops, performances, events, open sessions wherein we talk to people in real and meaningful ways about the problems they may have encountered due to COVID-19 or any other ailment that plagues them, their family, their community, their children. Like wherever we can be of service, that is our agenda. We don't come in with an agenda. We simply meet the needs of the people by asking them, how can we be of service? Because that is leadership, and that is literally who we should be as a community of experts. We should be servants of the people because leadership is service, and this project simply gives us the opportunity to do that. Next slide, please. As I shared, I've been working on this project in some facets since the start of the pandemic. And around May 31st, June 1st, the team and I began to survey Harlem's residents based on the overarching health of their neighborhoods and communities. And the next few slides are simply the questions that we asked. So it was a 10-minute survey that we put together. It was on SurveyMonkey. We surveyed about 40 people, simply asking them, kind of almost taking their pulse, if you will, seeing where they were. So the very first question was based on the quality of healthcare in Harlem. So I'll give you a chance to have a look at that. And then the next slide, can you advance that? Thank you, Rosemary. The next slide simply wondered about the context, meaning we know that maybe the healthcare isn't what it should be, but in times of need, is there help? And this was really exciting for me in some ways, because what we gathered based on the survey that was taken by, again, roughly 40 Harlem residents, is that we ascertained that while many respondents felt that Harlem did not have access to quality healthcare, many felt that they could rely on their neighbor. So they thought of the people in their communities as the resource. And that was really exciting. And I shared just many of you that, again, I live in Harlem, but so does my siblings and my mother. And I found that during the pandemic, she really came together with the neighbors to not only shop, but to ascertain, where the vaccine was, who needed it, how could they get there. And this was at a time when the community was really going through it in the worst kind of way. And so what I was most, well, again, I'm not romanticizing the impact of COVID-19 on communities of color. It really devastated Harlem and continues to do so. However, in spite of this, the community still came together and we survived, and that is Harlem. And so we have always relied on us. And again, back to this project, this simply will add the college into the community network, because we are literally in the heart of Harlem. But what I found in my 10 years here as a faculty member is that we can do more. And this project simply gives us an opportunity to do more. And while it initially involves, again, the School of Education, the School of Medicine, and the Division of Science, I'm hoping that it involves every department on our campus, because we are Harlem, and Harlem is us. We belong to one another. Next slide, please. In facilitating this with many of our Harlem partners, and this last slide is simply in the age range of our respondents. And what's really exciting about this is that we're moving forward, meaning that in the fall, based on this survey, that we will be meeting with Harlem's residents in small groups to ascertain which of these problems that they indicated in the survey they would like to start working on now. And how can we kind of come together and do that? So again, I was excited about the survey. We know that there's a need. We know that people care and they feel that they can rely on their neighbors. And we're simply trying to be a better neighbor and member of this community. Next slide, please, Rosemary. So lastly, this project, again, complements and serves the people of Harlem by making the intellectual and physical assets that we have at our fingertips available to the people of Harlem in real, tangible, and meaningful ways. So I hope this made sense, and if not, please refer to that white paper, but I appreciate you listening, and I am going to end it here, and I am happy to take any and all questions, and I see my team. Thank you guys. If nothing else, what this project has shown me is that we really are a family here. And I want the people of Harlem to see just who we are. It's not just me or Noel or Susan, but it is all of us. We are Harlem, and we can do more. We can be better stewards. We can be better neighbors. We can be better leaders in our community. And this just gives us an opportunity to do that. So while I'll take questions, I am hoping that my team members will unmute themselves and answer your questions as well, because while I am here, I am not Harlem. I am one of many, and many is us. So again, I'm stopping. Thank you. My team is here. Rosemary, if you could conclude my portion so that we can see everyone, and my colleagues and team members can help to answer questions that may arise.
So you're asking me to stop sharing my screen?
Please and thank you.
So I was to say, if there were questions during the presentation, you should put them in the chat. But since I didn't say that, if there are questions, feel free to unmute yourself and jump right in. Anna, I see you had a clapper. Any questions?
No, you have people who already post questions on your chat, so you should ask them. I was clapping.
I do? Oh, excuse-moi. Why do you, so there's a question here. Why do you think there were few young people among your respondents?
I think it was us. Many of us asked our friends and neighbors, and we are in the age of the respondents, but there are ways to get younger people involved, and we will do that, especially when schools are in session, and we can actually do some on-site visits to community-based organizations that have a younger audience, if you will. So the respondents simply reflect our ages, and I am over 45.
So I'll ask, can you elaborate, or maybe your team members also elaborate on specifically the research objectives that you may have outlined in the white paper that you submitted as well?
So the overarching aim is to help to endeavor to create a healthier Harlem. So this is that we're addressing needs that may have been exacerbated due to COVID-19. But as you know, Black and brown communities are marginalized and under-resourced. And because we do have a School of Medicine here, along with talented scientists and great educators in the School of Education, we can make we can make what we know, I guess, more public. Case in point, as you know, many people of color, despite being disproportionately impacted by COVID-19, there are still many of us who do not, will not take the vaccine. And I know Noelle shared a story about how, and Noelle, you can unmute, you can speak for yourself, but we talked about, you know, what is it that we can do to help Black folks in particular be less leery, if you will, of taking the vaccine. So maybe it's having questions in real ways and taking it well.
Thank you. Thanks, Terry. Excellent presentation. I think what really is very exciting about this, I'm a public health physician in terms of what I've been practicing for the last 15 plus years. The whole idea of community partnered research is really, has gained more footing. It involves in connecting with the community from the inception. So as Terry said, so we're not prescribing or coming in with an intervention that we want to try out an experiment and see what happens. I think, and I was an assistant commissioner at the New York City Health Department, and we were doing community sentiment surveys at that time to help inform the equity work around the COVID response. And a lot of the information we were receiving was completely opposite to what, you know, public health experts might think. And that really does emphasize the point about listening and learning from the community. And then the multidisciplinary approach of coming at it from the School of Medicine standpoint, School of Education standpoint, from the community standpoint, and bringing other people into the project as we go forward, I think would really position this to be a very unique sort of community-centered health research that's coming out of City College. And you know, the presence of City College in the public health landscape so far hasn't been as strong as it could have been. And I say this as a Harlem resident, as a person who works in Harlem. I think this gives us an opportunity to really write that and to do it in a meaningful way.
So one of the questions we asked that the committee addressed is, why is this the right time? Why is this the time to seed and grow this opportunity?
I think the state of the world in terms of the economy, the political activism, the far right and the far left. I think that interdependence is far better than dependence. We're realizing that we need one another. And because COVID-19 has such a devastating effect on communities of color, that we know that it's going to be more than just us. Like, it's more than just the scientists. It's more than just the educators. Everyone and everything matters. And by coming together as a collective, we can literally meet the needs of the people in an organic, sincere way that embodies, I think, the best of us. I mean, we all want to be healthy and happy. We just want to say that out loud and take steps proactively to do that. Now, yes, this is a response to COVID-19, but communities of color have been in danger long before COVID-19. We've been saying Black Lives Matter since the death of Emmett Till. So we know that there are many needs in the community. COVID-19 made clear that it affects us all, because it did impact, you know, it's a global pandemic, but it hit us the hardest. And when I say us, I mean disenfranchised people. I mean people of color, people in Harlem specifically, and that's still our population. Although we're gentrifying, Harlem is still Black and brown and under-resourced. And we have to find ways to build on the good work that's already happening. But at City College, I think we have an obligation, if you will, to the children of the people, because that's who we should serve.
So we have a question here as, do you have specific health specialty areas that you want to focus on? Maybe cancer, obesity, mental health? And if so, have you prioritized those areas?
As I mentioned, I have a colleague, Billy Clowns, who was also on the team, and he's a Harlem resident, and he already has mental health groups meeting with other Black men in the community, talking everything from child rearing to just being a Black man in Harlem and what does that mean. And in his mentoring work, I know he has monthly roundtable meetings in a Sylvia's Restaurant, that's the soul food restaurant in Harlem, where he brings Black men together just to talk candidly about issues that they may not share. I know he himself, he shared with me that he actually ran for city council a few years ago and he wasn't successful and he was quite depressed after. But people think that, you know, and Billy's a great looking guy, he's fit, beautiful wife and family, and you would assume that, you know, Billy's good, but Billy was hurting. And he found that people were surprised that, you know, he had these dark days and what does it mean to share that? What does it mean to grieve a loss, even of an election, but to want something and not have that come to fruition? And so mental health will definitely be part of it. My research looks a lot at Black girls and how they are treated in the school. So I know that I want to go out and work with Black girls, not just in the high schools on our campus, but in neighboring communities. So I say this to say that all of us as members of the community have issues that are close to our heart for personal reasons, because the political is personal and the personal is political. So we all have an agenda, but what we have to do and what we will do is collectively kind of triage it and see where are the low-hanging fruit, where can we partner with other CBOs, because again, this work is already happening, but how can we do it better and have a bigger footprint in Harlem? Susan, did you want to say something? I'm sorry if I kept
Yeah, is there a second? I don't want to run over.
Yes.
I just was going to jump in a little bit and just offer, maybe this goes back to one of the first questions, is that to me as we worked on this, the research becomes what happens when we do something different than we academics and health folks typically do in scientists. What if we start by engaging the community and asking them what they want and what they need? And so the survey was a very initial pass of that, and we would have loved to have had some young people. School had just ended, and so we missed that window to capture some of our partners, say at Philip Randolph High School here, where we also work with. And I think that gets to a lot of these questions, you know, like Anna's question, you know, there weren't any priorities because we shouldn't set those priorities. We should be listening to the community. And I think what we were going to learn out of this is less a specific result focused form of research, but a process. What happens when we do this, and what are the best strategies, and where might we expect to see differences? I think the young people, for example, would prioritize health needs in a very different way than older folks in the community. And we already saw a tidbit of that in our survey in terms of how the respondents prioritize things like violence versus access to medical care versus, you know, transportation, or things like diabetes, you know, things that might jump up. So, you know, when we have more time, as we continue to work on this, I think, you know, we'll get a fuller picture and start to see the results of what happens when you do research in a different way than we have typically done it in the academic sense.
So we've got 2 questions, but we only probably have time for one. We've got about 2 minutes left. So I'm going to try to take the easier one. Do you see an opportunity for our students to get involved in this project? Maybe under the lens of engaged scholarship or experiential learning?
Definitely. This is organic in nature. We hope to include everyone, and everyone means just that. So it's not just, you know, faculty or community members. It is students, it's children, it's anyone who cares about Harlem, and that's all of us. And so where it goes, and that's the beautiful part, it's where we say it goes, and we as the collective. So yes, I do foresee it in our future. I hope so. And it's just making the meetings available, online options, in-person options, going to specific sites to be, intentionally more engaging, but we are intentionally broad. We are intentionally diverse. We intentionally don't have the answer. That's the thing. We don't have a solution. We are simply, as Susan said, we're looking at the process. We are purposely malleable. And that's a real different step for many of us as scientists, as researchers, or, the sage on the stage, that faculty often we fall into those, those roles because we know it all, but we're saying that we don't. And that those closest to the problem are usually closest to the solution. They just need the resources and access to talented minds to bring it all together. And so we think that our next scientists and researchers, they're in the community waiting for us. We just have to bring them, we're just bringing people together. That's the beloved community.
Thank you. Thank you, Terry. Thank you, team. I think we need to move on to our next presenter. So let me share my screen again. And team 7, I think that's Yana.
Yes, it's us. Okay, thank you. And good afternoon, everyone. I'd like to point out that almost everyone from our team is here. So I'd like to thank them for all of the support in trusting me to present our proposal to you, but also please direct questions to them as you see appropriate at the end of our presentation. So our team is Team Climate Solidarity, and we are an interdisciplinary group of scientists, engineers, and designers across 4 divisions and schools of the City College of New York. We're brought together by our research expertise in climate science and environmental justice, and our commitment to an environmentally just future. Next slide, please. Our framing question challenges us to imagine if solidarity surrounding climate actions were leveraged to reimagine and co-create a future for New York City. Climate change and the increasing frequency of extreme weather events threaten the health and well-being of vulnerable populations, as well as the operations of vital public infrastructure, such as the housing stock in New York City and the electric grid. The climate crisis facing coastal urban areas is intimately related to the housing crisis and the energy crisis facing low-income communities of color. Currently, 1/3 of the housing stock in the US is at risk from disasters related to climate change, and by 2050, the number of affordable housing units vulnerable to regular flooding will triple. Low-income households already experience the double burden of high housing costs and high energy costs. Historically marginalized communities are also the ones most likely to experience blackouts during severe weather events and be the last to have their electricity restored. Building for an equitable future means transforming affordable housing into a model for a decarbonized infrastructure. Reframing housing policy and energy policy through the lens of climate justice also means reimagining how to build a resilient electricity and housing infrastructure where frontline communities have control over and ownership of both types of infrastructure. So why is the time now to do something? Buildings in New York City contribute more than 70% of greenhouse gas emissions. The city has already passed an ambitious set of energy and housing laws that set limits on emissions and that will eliminate natural gas from all new construction. At the state level, New York's 2019 Climate Leadership and Community Protection Act is heralded as the most ambitious legislation of its kind, but the state legislature has yet to pass any meaningful implementation laws to meet its goals. At the local level, the amount of funding and coordination needed for housing retrofits and new electric grid technologies necessitates the collaboration of multiple stakeholders. Therefore, we propose a set of scientific objectives with the explicit goal of facilitating the transformation of energy and housing infrastructure in New York City through collaboration with community and policy stakeholders. Next slide, please. We see the climate crisis as an opportunity to reimagine urban futures. The ultimate goal of our collaboration is to bridge gaps between data and design, analysis and action, top-down visions and bottom-up efforts in order to establish actionable plans to adapt to the changing climate. Next slide, please. Our collaboration imagines how solidarity around climate actions can be leveraged to reimagine the future of New York City via co-created scalable urban resilience projects. We will leverage diverse expertise across architecture, the social sciences, computing, and engineering, and work with community partners, regulators, and utilities stakeholders. Next slide. Our project has 6 main objectives. We plan to launch a web-based urban climate service platform for public dialogue, program evaluation, and decision-making. The web platform will include AI-enabled physics-based models of climate change at microscales, coupled with demographic projections of population displacement and infrastructural vulnerabilities due to climate change. We also plan to develop a pathway for low energy grid interactive affordable housing and launch a community-based energy infrastructure project in Harlem. Both the web platform and community infrastructure project will be co-created with community input. We'll formalize this input through a citizen science initiative, which we hope will lead to a standing institution located at City College for training the next generation of climate leaders. Next slide, please. Our objectives will pioneer a new interdisciplinary approach to convergent science that combines urban design, engineering, computer science, and sociology frameworks to co-create actionable climate solutions with community leadership and input. We'll break silos across public agencies, community organizations, and academia, and promote student engagement and leadership. Ultimately, we hope to train the future workforce of New York City for jobs in climate action and adaptation. City College already enrolls more than 15,000 undergraduate and graduate students of all ages and diverse backgrounds. Our students are already a major part of the local workforce and are the future of industries centered around climate adaptation. If successful, our project will not only make New York City a better place to live for our students and their families, it will also engage students in research and train them to become the climate leaders of the future. Next slide, please. So we have 5 interconnected work packages to achieve our objectives over the 3 years of CRV funding. Next slide. Our first work package will develop a web-based platform titled Climate Solidarity with consolidated data, interactive mapping, visualizations, and simulations for an ongoing engagement, community dialogue, program evaluation, and decision-making. The platform will also serve as an essential tool to converge research activities outlined in the rest of our work packages. Next slide, please. In work package 2, we will use physics-based urban climate models to simulate the impact of disasters related to climate change at microgeographic scales. We will then model the impact of climate change on affordable housing and critical infrastructure in New York City. We will also develop neighborhood level estimates of energy insecurity and building level energy efficiency. The models of climate change, housing and affordability, and energy insecurity will feed into demographic projections of climate-induced displacement. We will visualize the inputs and the outputs of the demographic projection models on our Climate Solidarity website. And this website will then build simulation scenarios to facilitate what-if questions that will identify data gaps for citizen science engagement. Next slide, please. In work package 3, we will develop a pilot project titled Community Energy Cells, in which distributed energy resources and controllable loads, such as photovoltaic batteries and electric vehicle chargers in close geographic proximity are virtually aggregated as a single controllable entity with respect to the main power grid. This is an emerging aspect of power engineering, which converges with advanced AI and machine learning techniques. The resources within each energy cell can be owned by individual households, buildings, but also shared amongst community members with reliability and economic benefits shared amongst all participants. Our research questions center around evaluating the feasibility, benefits, and barriers of application of the energy cell concept to energy insecure New York City communities. We will simulate energy cell scenarios in collaboration with Con Edison, and then we will use the visualization platform that we had already developed in Work Package 1 and other community engagement activities to gauge acceptance and develop marketing strategies to approach the general public and policymakers about this idea. Next slide, please. In Work Package 4, we propose to conduct program evaluation through the creation of a Community Climate Response Index. The index will be co-created with communities and community organizations through a participatory process and citizen science, and later evaluated by means of trial and adoption. The creation of the index serves to localize the types of climate events and local knowledge of those events to produce plausible short and long-term responses to such events. This index will also serve as a communications mechanism to assist in the dissemination of information to policymakers and public agencies. The index and the citizen science described under our next work package will establish a new model for evidence-based policy making from the ground up. Next slide, please. In our last work package, we harness our own participatory research assets as City College researchers in the classroom and design studios with local community organizations, with policymakers, public agencies, and utilities. As instructors of undergraduate and graduate students, we will engage students in the planned research. Several of our PIs have already adopted lab models and design studios when training students to apply research methods towards collective projects. With this expertise, we will develop cross-disciplinary curricula that prepare future leaders from underserved communities to both undertake and act upon research, thereby shifting power imbalances towards equity. We'll invite participation by local stakeholders, including Manhattan Community Boards 9, 10, and 12, as well as several local community organizations currently working with the J. Max Bond Center for Urban Futures. Through participatory processes such as the development of the Community Climate Response Index, citizen sensing of urban heat, air pollution, and other environmental hazards, as well as focus groups and yearly community workshops, will engage community voices at the early stage of climate adaptation plans and technological development. Through the citizen science component of community engagement, the research project will transfer the necessary technological skills and models to empower communities to collect their own data for climate actions using local knowledge and local leadership. Next slide, please. In year one of the project, we anticipate setting up the online climate scenario platform, and we'll do the necessary scientific work on the development of the climate risk assessment metrics and the microgrid model. We also plan to work on our citizen science data collection tools and on outreach to community groups, regulators, and utilities. In years 2 and 3, we will launch the community microgrid demonstration project in Harlem and refine the microgrid and the climate risk assessment metrics through community input and citizen science. In year 3, we plan to integrate the citizen science components of our project into the City College curriculum. Next slide, please. Each work package described above combines expertise across multiple academic disciplines, schools, and divisions. Our team combines expertise in physical space design, cyberspace research, demography, policy, community participatory research, and citizen science. The online platform, the climate futuring scenarios, and the energy cell pilot will all center the input of community stakeholders who will play an integral role in the project. The climate futuring scenarios will combine environmental science with AI modeling, demography, and sociology. The energy cell pilot will combine power engineering with machine learning and AI. The community engagement portion of the project will combine expertise in sociology, policy, and design, and will ultimately inform all of the rest of the project through community and public agency partnership. Next slide, please. Our team will be co-led by a multidisciplinary management team from sociology, engineering, and architecture. Myself, Dr. Zhang, and Dr. Mohammed will form an executive leadership team to oversee project personnel and to meet project milestones. We also plan to recruit a postdoctoral scholar to serve as a project manager to coordinate activities across the timeline and supervise the work of research assistants. And our last slide is about our funding plans. So our team members are well-recognized experts in their fields and have already had success with major funding from agencies such as the NSF, the DOE, and the DoD. But now is the time to take a truly convergent approach to the climate crisis by seeking major external funding as an NSF center amongst a variety of other sources at the federal, state, and city levels. Even though the immediate goal of our project is to secure external funding opportunities, our long-term vision is to create an active platform of collaboration based at City College that champions climate justice and adaptation. We embrace our team's truly interdisciplinary nature and anticipate other means to sustain our research efforts, such as the publication of book series, the creation of a standing institution for research and training at City College, as well as annual conferences and community workshops tied to local climate justice issues. Thank you for your time.
Thank you. And I will follow Terry's lead and stop sharing my screen so that we can see one another and I can see the chat. So there are questions here in the chat. How can this project be applied to our own CCNY campus?
Should I start? I think when we started building the project, we actually were thinking specifically about how we can harness all of the opportunities that are available here at City College. So some of us have actually collaborated on small scale projects that are very similar in spirit to what we propose here. So for example, with Pratap Ramamurthy and myself, we've done a air quality pilot in Harlem and in the South Bronx that has included participation from community members and community organizations. So my colleagues can speak about their own experience with engaging community partners in research as well, but we thought about what can we bring to the table in terms of things that we've already done, but things that we can now do together, not only with our own community partners, but also with our students. When we talked about how to approach this project, I can give you another example of what Professor Catherine Chen, who's the chair of the sociology department, shared with us. So she's been doing her methods class as a lab where she essentially teaches students how to go into communities and take notes on what's happening there, and then partner with community residents on projects. So for example, she's had a student who turned a project that they did for her class into a bigger community engagement project around connecting seniors to green spaces in New York City. So we not only have, I think, the scientific expertise across different departments and divisions where it's high time that we start working together, but we also have this our amazing students who do amazing research and who are our link to our communities.
So Professor Zhang, you also replied. Do you want to say anything?
Sure. I'll just add maybe 1 or 2 sentences on what I said in the chat. So basically, here at Spitzer School of Architecture, we already have this kind of a what we call what's called roof pot. So basically, Spitzer roof pot. It's actually has solar panel and combining with urban agriculture, and producing energy for the building itself. So that could be served as a pilot and a prototype in a way to inform some of the design decisions and inform this project. And also what if we just transform every rooftop on the campus into this project?
So there's another question. Thank you. Given the importance of trees and open space in reducing urban heat, absorbing floodwaters, and addressing root causes of climate change, do you see a need for biodiversity in your project?
I can actually respond to that. And Catherine Stephen Nordenson and I myself, we are members on this team, and we are from architecture school and landscape architecture program. That is actually what we concern every day. How to engage with urban ecology, how to engage with urban biodiversity, with a lens through environmental design. And we do actually concern about diversity, not as a sort of a singled out problem, but it's always social, because we don't isolate environment from social. We see them as one one thing, and we have to sort of think together and use design as a lens to address these complex and wicked problems.
Thank you. Another question. In your objectives, you mentioned microscale climate projection. How and who in your team will achieve this?
This is Pratap. I'm also part of the team. I'll be in charge of running the physics-based climate models at various scales.
Work package 3 talked about energy justice. Can you explain what you mean by that and how you will accomplish that?
Should I take it first, or does Ahmed or Michael, do you want to respond?
The clock is ticking.
Okay, so I will say, so the way we see energy justice, at least in the short term, is thinking through models of how to make the energy grid more stable, especially for low-income communities. We know that nationally in the United States, when public or rather private utilities such as Con Edison make decisions about the electric grid, they usually do not prioritize low-income neighborhoods. So what happens is that low-income neighborhoods are much more likely to experience blackouts and are also much more likely to not have their power restored after a potential blackout. But there's a second component here that has to do also with cost. So because low-income communities usually live in very inefficient housing, they pay multiple times more on their energy costs compared to people who can afford newer housing with better isolation. So that's also part of energy justice, where the housing in which we live makes energy bills much higher. So for our concrete project, we're not only working on the supply of clean energy to communities, but also the the potential of energy cells to make the cost of energy much more affordable. And
I can amplify.
yeah, go
I
ahead.
can build on that just a little bit, Yana, bringing in the elements of workforce development and local participation in energy projects. These are things that are right near at our grip, right within our grasp. We actually, a group who are on the team submitted a proposal to Department of Energy, was very favorably reviewed, not awarded, but could readily go back to create a local microgrid company that would support buildings throughout the community, the Harlem community, and complying with New York City laws that require carbon reductions, creating skills and jobs in the process. And, you know, it's that self-creation of energy that is part of energy justice as well, the jobs and skills that are required.
Thank you. A couple of more questions. The models and the data integration modules that you are proposing to place online, are they already developed or will they be created during this research?
So we have the models, but they've been developed separately.
It's a mix. There are many modules.
I'm sorry, can you say that again? Was that
Michael, I think, Michael, you go ahead. Yes.
I'm sorry, my connection is a little shaky, so I was lagged, sorry. But there's a lot of curriculum that is in existence through various members of the team that is directly applicable. Other material will be developed. There's integration to be done, but you know, there has been considerable work done on these areas by members of the team.
Yeah, so the integration, I think, is the real strength as we see of our proposal, because we have many years of experience in energy modeling, in climate modeling, in demographic modeling, but that all needs to be put together as part of this project.
So there are a number of conversations going on in the chat, which is great, but I don't see any more questions. Are there any more questions that maybe I've missed or that you want to ask? If not, thank you. Thank you for the presentation, and we'll move on to Team 8. So let me share my screen again. Try. And Team 8, Anna, when you're ready.
Hello, can everybody hear me?
Yes.
All right, well, thanks for having me. It's great to see everybody online. Anna Carnaval, and I am talking about the Sugar Maple Team Project. Just a little background on this project. I recently came back from Switzerland when I was in the World Biodiversity Forum. It takes place at the same spot where the World Economic Forum takes place. And one of the keynote speakers was the chair of the Department of Economics at University of Zurich. And his title of his talk was, "The current financial sector is incompatible with biodiversity protection. This is a topic that has been in the back of my mind and the back of the several other minds of students and faculty and staff at City College. And this project is sort of a reflection of that. We came together right before the pandemic, several of us, and got involved in an initiative to create a cross-disciplinary cluster interested in biodiversity and environmental change issues. And we sort of went dormant with the pandemic. So when the CRV announced this competition, we came together and several people said, I would love to work together on something at the interface of ecology and economy, and really bringing the discussion of biodiversity into light. And we well, not me, I'm not a botanist. Somebody brought up the issue of we should make sugar maples our thing. And the reason is because sugar maples are crucial ecological, economical, and cultural, have crucial economical, ecological, and cultural roles in the New England area and in the state of New York. Ecologically, these massive trees participate in carbon cycles and geochemical cycles and provide habitat and food for a wide range of organisms. Economically, they really provide maple syrup, which is a very strong element of the economy of New York. New York is state as the second producer of maple syrup in the US. And it really dictates or contributes in a large extent to the fall tourism economy as well. And culturally, it really provides a sense of place, a sense of belonging to the New York region. So we felt that sugar maples could be a really great target system to work together as we address two main issues that I'm bringing up here. How can we promote individual and group actions that will lower the anthropogenic pressure, economic pressure on natural ecosystems, using New York to act locally, and how to facilitate adaptation to future environmental change. So this is where we're coming from. Next, please, Rose. So we are a group of people from many different departments and schools. From biology, me and Mike Hickerson are bringing expertise in integrative biology, species range, climatic controls of species distributions, population genetic and barcoding, DNA barcoding. And Earth and atmospheric sciences, Kyle McDonald is really bringing lots of expertise here about remote sensing technology and applications and using drones to obtain information about colors. Andrew Ryman from geography at Hunter is bringing expertise in sugar maple physiology, as we're going to look at sap flow, for instance, to produce sugar, maple syrup, and plant responses to changes in the amount of snowpack. And then we reach out to non-scientists because they're crucial in making this alignment happen. So Jean Krasno from the political science department at Colin Powell will help us think of how to change environmental policy around climate change adaptation and negotiation processes as we work with local stakeholders. Rebecca Albee from the art department is going to help out with photography and how we reach out to the general public about this issue. And then from the English department, Emily Roberto and Michelle Valadares are really bringing in creative writing and communicating climate change and teaching us how to do it together. Next, please, Rose. When we had our recent workshops, we were told to funnel and reduce the scope of our question to make it an attainable question that we could really pinpoint what we're going to do and why. So while the big framing is the one that I presented, how can we make this a world where we can value biodiversity as much as we value money? How can we have ecology and economy together? Our framing question, the really directed question is, what can we study out there in New York, in the state of New York, about how biodiversity, here represented by soil microbes, and climate impact local economy by impacting the maple-related industries, sap production, and fall foliage. And I have here just a map on your upper right side, just showing you how projected maple syrup production is expected to change due to climate change in the near decades. So this is a real pressing issue for the state of New York, being beyond just interdisciplinary in nature. Next, please, Rose. So the statement is the big statement, like Rose asked before, how does this, what is the big question that is being addressed here? What's the big challenge? The big question, the big issue here, the big problem is that climate and habitat change have been threatening biodiversity and all the ecosystem services that it provides. And as such, economy impacts ecology, but ecology feeds back on economy. So they directly impact economies and human well-being worldwide. So the planet needs some sort of shift in the way that we see this economic paradigm and the market forces that are shifting the balance in our planet. And we all think that altering this paradigm requires changing human perception. It's more than just scientifically documenting this change. We've been scientifically documenting and studying all of the changes that anthropogenic climate change lead in biodiversity, but we need to change human perception. We need to change human value. We need to change human behavior if we're gonna change this pathway. So we wanna help or try to help set this paradigm shift in motion. And for that, we wanna act locally. So we want to engage our scientists, our students, with political scientists, with artists, with writers, and a diverse community of stakeholders. We cannot present this to many funding agencies, but we think that the CRV would be a perfect place to get this started. Next, please, Rose. So the narrow objectives are we want to use sugar maples, which is one staple of New York's economy, and the maple-related industries to 4 main objectives. One is really, say, the scientific part of it is to quantify, to measure in the field, and to model how does biodiversity in here, measured as the soil microbiota, the fungi and the bacteria in the soil, and climate can impact the state's economy through their effects on the production of maple sap, the composition of maple sap, and fall foliage, the colors, the vibrancy, the amount of colors that we have. This is a main scientific objective. To do this, we don't want to do it as an ivory tower. We want to engage maple syrup producers in this data collection, in the analysis, and in the discussion. We want to combine these measurements with art and communication, with photography and storytelling and creative writing to reach out and engage the general public and promote change in perception, change in values, change in the way people see and manage and conduce their own lives. And lastly, we want to make all of this research parallel to the education that we provide at City College. So we want to converge our teaching with this research project by engaging students from multiple schools, often together, sometimes separately, by bringing groups of mixed disciplines to the field, creating new interdisciplinary courses on campus, and adding hands-on training to existing courses that we're modifying in earth and atmosphere science, and in biology, in political science, and in English. Next, please. The merits, intellectually or scientifically, integrating this environmental, physiological, and genetic data, it's complex, it's challenging, and it would allow us to better understand how climate and the biodiversity of the soil impact maple sap production, impact sap quality and fall foliage. We want to develop new statistical analysis and new models to identify how we can help sugar maple trees persist and the industry that they support persist, given the climatic and environmental trajectories that we're seeing. And we want to use this project to establish a pilot program to study and facilitate adaptation to climate change. We originally had thought of putting this as a main objective of our program, but we realized very quickly that this would be a risky objective to have as a main thing of a promise to do. So we want to use this opportunity to maybe establish a pilot program and test if we have the methodologies to allow for that. Broader impacts, we want to, again, foster change in public perception of global warming and the value of biodiversity, and create hands-on, problem-based, cross-disciplinary training on campus with students and faculty from different schools working together on the common goal, all around sugar maples. How cool is that? Next one, please. So the data, the technical approach we have in years 1 and 2, we're gonna do data collection. In years 2 and 3, we're going to do data integration and also data sharing and outreach. And we're really putting money on putting people from different disciplines together in the field as a major, element of catalysis. And this actually builds from the experience that several of us biologists have, that when people are in the field, they are disarmed, their vocabulary simplifies, they are more relaxed, and they can talk to and listen to each other in a much better way. So we are going in years 1 and 2 to put faculty and students together out in the field, characterizing a lot of things from 10 maple stands across different soil types and climates in the state of New York. We're going to characterize temperature, precipitation, and snowpack. We're going to document leaf colors through chemical analysis, photography, and drones. We're going to characterize sap flow and sap composition, measuring sugar. We're going to describe the soil biota. We're going to sample the soil and use meta-barcoding, barcoding the DNA of the bacteria and the fungi in the soil to determine the diversity of microorganisms. We're going to interview local sugaring communities to identify their practices, the policies that are relative, what are the narratives that they have, what are their stories. And we're going to involve students in the field collection from different courses. Biodiversity, climate change, and the political process, which is a class that I already teach with Jean Krasno. Creative writing by Emily. Intro to Biotechnology Lab, which is a class that I teach with Chris Lee. Environmental DNA, which will be a class that Hickerson will lead. And a new FICOS course that I think would be very cool that we want to create together. Next, please, Rose. Year 2 is data integration. Years 2 and 3, we want to identify the statistical relationships between how's the climate, how's the biodiversity, and what do they do to the sap flow, to the sugar concentration in the syrup, to the colors of the leaves. We want to see what are the impacts of future climate change given what we see in these correlations. We want to ask, how can we integrate this scientific data with the social science data that Jean is going to be collecting, or the narratives that Emily is going to be collecting in the field? And how can we involve students? Again, we're going to bring students into capstone projects and environmental projects using these data to analyze and combine across fields. And approach 3, years 2 and 3, is the public outreach. At the end of this, we want to have a big all hands on deck workshop in partnership with the Appalachian Mountain Club, which already has a partnership with Michelle Valadares, to report back to the maple producers who have been collecting, discussing this data with us in the field, share the findings, and delineate with them what are the local policy proposals that they can do, given what are the trends that we are collectively seeing. We want to take our students to a nature exploration retreat when we do that, so that they actually experience some of this in the field. And lastly, we want to see if we can organize a small public exhibit to showcase the art, the writing, and the science, to a broader community in Harlem. Next, please, Rose. Thank you. So we have a ridiculously long list of milestones that are not going to go in detail here, but the main thing is we have 4 maple stands to sample in year 1, 6 maple stands to sample in year 2, and all the analyses are ongoing. Next, please. We have qualifications in all of these areas. McDonald works with documentation of climate, vegetation, and soil freeze-thaw processes. Both McDonald and Ryman work with physiological data. Ryman works with sap composition and photosynthetic physiological analysis. Mike Hickerson and I work with DNA data analysis. Jean Krasno brings the political science and how to bring negotiations to change policy. And Albie, Raboteau, and Valadares are our creative expression people and bring lots of expertise in these areas. Next, please. This is our constellation. It's showing all of us, and the other circles are graduate students that we want to attach to the grant proposal. And this concentric, 3 concentric color circle, to your top, is a postdoc that we want to bring together to really make sure that we have a glue across all of the science and the non-science. Next, please. We want to do monthly meetings in hybrid mode for all of the decision making with all of the faculty, all of the postdocs. I am a very participatory, community-oriented PI, so we will draft a community agreement on our first meeting to ensure that we have a respectful, inclusive, and friendly environment, especially if we have field trips. It's really important to set the rules of the games. The students will have representatives to contact me if they have any conflicts. We will work together in the field across these joint field expeditions. We will have Slack and emails to communicate, to attend to the different generations that are part of our team. We'll have young and more senior members, and we'll have both to ensure that everybody's getting the messages. Next, please. Our idea is to reach out to NSF, to NASA, and to USDA later on. I have been very involved with many initiatives at NSF through Dimensions of Biodiversity program. I've led a multi-million-dollar project there, and I think that we are very well poised to submit a follow-up program to Biodiversity on Changing Planet or critical aspects of sustainability. McDonald has very strong presence at NASA with the Biodiversity Ecological Forecasting Program and the Applied Sciences programs. And Andrew Ryman has very good teams with links with USDA and the National Institute of Food and Agriculture. So we really see many different ways of expanding this, be it with the adaptation genomics part of the MAPLE that we want to explore, or how to expand this to meet economical models, economic growth models later on. I think next, maybe that was it. Thank you, and I'll take your questions.
Thank you, thank you, thank you. And I think we have questions over here that I need to catch up on. Have you thought about collaboration with SUNY?
Yes, Amy, SUNY and also both Andy and Jean have very strong ties to maple syrup producers and sort of journalists in this area. So we have a fairly big list of folks who we want to reach out once we have an understanding of, what is going to be our core team here. I totally agree with you that we have many other folks around us who can help us. Even Cornell also has a very strong sugar maple group. So we should look beyond City College for this for sure. If you have anybody specific that you know and love, I would love to hear that name.
So have you identified any companies or producers?
Yes. So that, we have in our original proposal, the pre-proposal, we actually had included a list of producers that have ties already with co-PIs or collaborators on this group, because we want to use some of their maple stands, right? So that's part of the program, is really to make this not just the science for the science, but the science for the community of producers. They are the ones that are really living this. So that would be very important right there.
And then also, what about incorporating younger students, maybe a citizen science component?
We could definitely, so younger students as non-CCNY students, right? Yeah, we have not thought of that. We could think of that. There are lots of students can very easily now connect with nature through iNaturalists or other apps that they have on their phone. So it would be very easy to, on the fall foliage color part of the project, for instance, say, help us document the coloring of, your forests, and have people submitting images and doing a collage. That is a very great way of reaching out to the public, is through elementary, middle school, high school students for sure.
So my question is typically, why now?
Why now? Because the world is going to hell, Rose, and we need to change this trajectory pronto. And I think that we need I think when I say I'm saying we think that to change this, we need to do more than just show data. We need to change people's emotions. And that's why we think it's so crucial to use this opportunity to really bind the science with the artistic expression, with writing, right? With politics. And I can see that Michelle Valadares, who's also a member of this project, has her hand raised and probably wants to say something about that. Can I give her the power to speak up?
Of
Okay.
course.
Michelle.
So thank you, Anna. Thank you, everyone, for joining in. Yes, on this point, we're very committed. I'm the director of the MFA program in creative writing in the humanities. And Anna and I and other scientists go way back, trying to figure out projects to collaborate on, because we as writers definitely see this as the pressing subject of our time. We did collaborate through the president's office. We got an invitation from the Appalachian Mountain Club to bring up our CCNY students, and specifically because in those arenas, in those public spheres, there are not a lot of diversity. And we were incredibly successful. We took 2 classes, a dramatic playwriting class and my poetry class. The students were hungry to be out there. You know, we didn't have a scientist on that group. That was this past semester, but in October, we're planning to invite Anna and other scientists on the team to come up and meet with the students and talk about the Sugar Maple Project. So I think on many different levels, this is urgent, but for the humanities, you know, those of us who write creatively or write nonfiction and prose, it's critical. This is also why Emily Rabateau has been writing on this subject for a while, and we've made her class, Climate Writing, open. It's a graduate class, and it's open to CCNY graduate students across the university. So we want to implement this in our program as well. So yes, I mean, I'm just throwing in a few things from the humanities side on why we feel this is critical, and particularly on this subject. Thank you.
Thanks, Michelle. And I think Mike wanted to say something. Mike Hickerson is also on the project and he's here. He wants to talk about the eDNA barcoding. Mike?
Oh yeah, hi. I'm just basically I put in the chat window. Yeah, it would be totally easy and to involve rural students with urban students, and I just that's a great idea. The idea for the course is to bring CCNY students upstate at various sites, but we could like reach out and involve local students who would meet us there at each of the sites and involve them with the eDNA sampling. And these kits are already set up to just mail to people, and each of you can like get one for like $30 and go out in your backyard and sample the soil and send it back, and you get like all the species that are the microbial species that are in underground in your backyard or somebody else's backyard or wherever. That's all.
So a couple of more questions. I think we may have time for 2. I'm trying to see the 2 that I'm going to read here. But the economics depends on the climate projection in the state level. Do you have someone on your team that is good at predicting that or can do that?
Yeah, we don't have a climatologist. Maybe I'll have to knock on Jimmy Booth's door and help us identify that. But we do have, our students have worked with the New York PCC, the New York Program on Climate Change. So we do have ties with other folks in the state who are doing that, not necessarily on campus, but other folks on the state. Yeah, we would need that. And eventually, if you want to do anything economic, we need a whole aspect. Like, as you see, we have nobody from economics right now. It's really the science, what it does to the products, and how we can tie in that with public perception and emotions and changing lifestyles or ways of seeing. The economics would have to be like one of these follow-up projects for sure.
Okay, one last question, then we have to move on. What What specific innovations or technologies do you expect to come from this project?
Yeah, so we think that the innovation comes from the integrating the data. So the innovation will really come on, well, from a scientific perspective, the innovation will come from integrating this data and creating models that are really putting together the environmental samples with the, microbiological samples and the colors of the leaves or the vibrancy of the leaves or the amount of sugar in your maple syrup. So that is really sort of novel in biodiversity science, and very challenging still, right? The other, I still feel that is very innovating to put artists and scientists and creative writers together. And maybe we are in the mess that we are because we haven't been doing that. We've been siloed so much. So if we can get people's emotions changed because we are allowing for conversation across these silo disciplines, man, that's a big innovation. That's something to write a paper about, I think. That's a science paper, right? That's a big thing. So we're not promising we could do that, but we would love the freedom and the support to try it.
So while I switch to the presentation mode, Kyle, you have your hand up. You want to answer us?
Oh, I'm sorry, Kyle, I don't see you on the thing.
Did you want to say something in that respect?
Kyle is also a member.
Yeah, I just wanted to follow up on the issue of climate projection. What's relevant here isn't what people think of as just traditional climate projection, like where the weather is getting warmer and where climates are changing at that point. You have two aspects. One is, the niche where the maple trees thrive, but what drives the sugaring season where the maple syrup is actually derived is that freeze-thaw diurnal change process that extends over some weeks in the early spring before the leaf out occurs. And that's where the remote sensing aspects come in for looking at freeze-thaw dynamics. And that is also highly relevant to the ecological forecasting component of this, because that's a parameter it's typically very much neglected in all the climate models. They don't really directly model anything that is directly observationally dependent on freeze thaw. So we'll be spending a lot of time on looking at that freeze thaw transition and how it's changed over the last 30 years and where it's projected to go to in terms of syrup production. And then there's different methodologies for syrup production and derivation, how the sap is extracted from the trees, but that's another topic to talk about later.
Thank you, Kyle. We got to move on. I know you're the next presenter, and we agreed that you would do your own slides. I have a slight modification for that. Can I do your slides? And then when we get to the videos, I'll switch over to you. Is that okay?
Yes, it's okay.
All right, so that's how we're going to do it. Floor is yours, Shi.
All right. Yeah, thank you, everyone. Thank you, Rose. And first of all, let me briefly introduce our team members. So I'm Shi Chen from Chemical Engineering in GSOE, who Duan is from School of Architecture. Daniel DeSavo is from Political Science in the Colin Powell School. And Raymond Tu is from Chemical Engineering in GSOE, and Charles Ross-Marty is from Civil Engineering in GSOE. Next slide. So our team aims to develop a unique evaporation energy harvesting technique and consolidate a new research field of hydroscience. So our framing question is, what would it look like if we could create a new form of sustainable energy? This is our dream, to create energy harvesting system that can continuously harvest energy from open water reservoirs to produce electricity, as shown in the picture. Next slide. So actually today we already heard lots of topics about the climate crisis, climate change. These days we also keep hearing this news about the record high temperatures. We know at some point we have to move to much cheaper and more sustainable energy sources. But unfortunately, our current technique is not good enough. For example, solar power is still too expensive, and both solar and wind power suffer from intermittency issues. Next slide. So on our planet, actually, there is another big energy transfer we never pay attention. It is evaporation. So many of us may think that evaporation is very slow, it cannot be useful. So actually, evaporation is really, really powerful. If there's no evaporation, we would never had any hurricane last year. No cloud in the sky, no rain at all, much less, and also much less windy. So evaporation is a major control of the whole water cycle on our planet. Actually, the hydropower we are using right now is a downstream energy form of evaporation. However, we had never harvested the evaporation energy upfront. Next slide. The videos. Can I share my screen?
Oh, sorry, you didn't hear me. I'm going to stop and you're going to start.
1 second. So about 7 years ago, we have developed the first engine that can directly and continuously harvest the energy from evaporation. For example, right now, I'm showing oscillator engine. Initially, engine didn't work. After we pour water underneath the engine, it can be Coke, tea, seawater, doesn't matter. The engine will start off automatically like this. So the moving part inside will keep doing this oscillation work until water dries out. This moving part is made of material we call water responsive material. This material can swell and shrink in response to humidity changes. For example, right now, if the shutter is closed, and then if we have water underneath, the chamber inside the engine will be humid, the material will swell and hit the trigger, open the shutter, and then the humidity inside the chamber will go down. So the material will shrink, hit another trigger to close the shutter. So within this process, we just need to make sure the engine will never reach equilibrium state. And so we have another kind of engine. This is a rotary engine. The left chamber is humid. You can see the white color stuff. Actually, that's the white paper. After we insert these wheels into the chamber, these wheels will start to rotate, and they will continuously rotate until the chamber dries out. Can I keep going? I think I have another video on the next slide.
Yes.
So actually, after we have this kind of we have mechanical energy, we can do many different things, right? So we can, first of all, if we connect the oscillator engine to a generator, we can use it to generate electricity. If we put the rotary engine on a small toy car, right? So the power can move the car forward. And actually, since we developed these engines, actually we keep hearing suggestions from many different people. So they say, hey, you have very good toys, right? So you can go outside to start a toy company. And we really believe our technique is much more than just toys. Rose, you can come back to this, to share your screen.
Okay, if you stop sharing, okay. There you go.
So in theory, if we use our technique to generate electricity, the cost can be 1,000 times cheaper than current renewable energy. Because evaporation happens day and night, actually our technique can also achieve on-demand power delivery without using any energy storage devices. But however, our technique is still in its early stage and face multiple challenges. For example, water responsive material is the key component of our technique. Actually, when we developed the first device about seven years ago, we didn't know how to scale up our water responsible material. But recently, our breakthroughs in fundamental understanding of water responsible mechanisms and the large-scale water responsible materials make it possible now to scale up our evaporation energy harvesting devices. Next slide. I'm sorry, this one also have a video. Sorry about that. So our proposal targets key technical and marketing milestones of prototyping, performance metrics, and marketing strategies. So to demonstrate the potential of our technique, we need device definitely bigger than these toys I just showed to you. So thus our technical objective will focus on the development of high scalability water responsible materials and lab mesoscale energy harvesting devices. So to bring the potential of the evaporation energy harvesting technique to a wider audience, our marketing objective will focus on the feasibility studies, including the theoretical potential, intermittency, environmental impacts, cost effectiveness, and the scalability, as well as the development of marketing strategies for policymakers and the general public. Rose, can I keep going? I think I have videos in the next slides. I didn't change anything, basically.
Yes, keep going.
So the intellectual metrics will include both physical aspects, such as power production and material efficiency, and techno-economic parameters to inform deployment challenges and opportunities across the nation. So we envision that if successful, our invention could provide pioneering method for society to harness the untapped energy source of natural evaporation and lead to a new source of clean energy whose power density is comparable to the current solar and wind farm, but at a much lower cost. For example, we estimate that if we only do one layer, actually our technique, we can do multiple layers. We can integrate everything in 3D. But if we only do one layer, the annual power density can reach 10 watt per meter square, which is comparable to the current solar and wind power. And for example, if we cover existing open water area in US, the total energy production capacity can reach 3 to 5 gigawatt, which is about 70% of the total electricity generation, US electricity generation in 2020. Also, we estimate that if we use our technique to generate the electricity, the price can be lowered to 2 cents per kilowatt hour. So actually, Tu and I have recently modified Silk to exhibit really high water responsible performance. For example, as shown in the video, our modified Silk can reversibly lift the load, which is more than 1,000 times heavier than the Silk itself. And if we consider the energy density of this kind of a Silk, actually it is much higher than those of all known muscles. And in Objective 1, we plan to develop this scalable Silk-based water responsible film. And we will target critical benchmarks of water responsible power density, efficiency, scalability. So we will also use other materials for including spores, petroglycan, cellulose, co-polypeptides as backups if the Silk-based water responsible material fail to reach the performance targets. In Objective 2, we plan to build a series of lab and mesoscale devices that are easy to configure for different water responsible materials. We also plan to create a plant-based evaporation powered air filtering system targeting the initial customers in the city. So 3 other recently patented device configurations will be used as backup. Rose, I think I don't have any videos in the following slides.
Keep going, Dr. Chen.
Okay, thank you. And the feasibility analysis is critical to customer discovery, scalability, commercializing, and also commercializing our technique. So in Objective 3, we will develop series simulations that describe the whole energy conversion and transfer processes and determine the theoretical potential of the system. So the simulation will be informed by the data from experiment and also will in turn guide the device optimization in Objective 2. So our preliminary result already suggests the power production of water saving potential of the technique. For example, here I show you a blue colored map, right? So this is the water saving potential. Let's see in California, there's a huge water loss every day due to evaporation. If we put our device on top surface of water and while generating electricity, the device will also slow down the evaporation rate. In this case, we can also save lots of water every day. So for example, in California, we can roughly save about 6 millimeters of water per day while generating a meaningful amount of power. So in Objective 4, we will collect information from Objective 1 to 3, developing marketing materials to pitch evaporation energy harvesting technique and the contact with relevant agencies. So we expect that by the end of the first year, we will reach milestones, including fabrication systems for high scalability water responsive materials, lab scale rotary devices model to simulate the performance of rotary devices, and information collection and analysis of existing renewable energy. So by the end of year 2, we expect to have the cross-linking dependent water responsive characteristics of Silk and its composites, self-powered indoor purification system, and models that can predict the potential of the evaporation energy harvesting technique, and also the contact and materials to pitch the evaporation energy. So by the end of year 3, we expect to have a series centimeter scale Silk-based water responsive materials with tunable water responsive properties, a meso scale about 10-meter scale rotary devices. The theoretical potential of the system for applications in electricity generation. So over the project period, we'll also deliver conference presentations, create videos, media coverage, on-site visit, and publications in major newspapers. We also expect to create develop business plans to move our technique to the real world. The team consists of experts in engineering, material science, energy analysis, product design, public policy, which are crucial to address current challenges and propel our renewable energy technique to a whole new level. So I'm also the key inventor of the proposed energy harvesting system. So our team also have a successful track record. For example, our recent work about the fundamental water responsive mechanisms and the scalable water responsive materials has been featured on the covers of Nature Materials and Advanced Science.
5 minutes.
And directly relevant to the proposed work, Dr. Tu is expert in biomaterials, and Dr. Tu and I has co-developed Silk based water responsive materials, and our team has actually invented a series of evaporation energy harvesting devices. Dr. Ardoin has completed significant work in plant-based air purifying system. Dr. Rose Marty has led several energy analysis projects focused on both regional and national electrical energy systems. And we have also published some preliminary model that can predict the potential of our technique. Also, Dr. DiSalvo has conducted extensive research on public policy processes and political communication in the US. So the project, the work on this 3-year project will be performed in the labs of 5 collaborators, which each collaborator leading different sub projects. And the 2 and I will provide water responsive materials and the water responsive characteristics to the Air Force in the device development and modeling. I and Aiduan will provide the device properties to the Air Force in the modeling, feasibility studies, and the marketing strategies. For Smarty and I will provide simulated device performance metrics to support device development and marketing strategies. And the DeSalvo and I will collect information to develop marketing strategies. So I will coordinate all proposed effort. So the team will meet every month to share results, and we'll also gather once a year for a day-long in-person retreat to promote further interactions. So the support from the CRV, we expect it will not only allow us to make the first transformative progress to move the technique from the lab to the real world, but also position CCNY at the center of this emerging field of high growth science. So the integration of our effort will also inform the scientific community, policymakers, and the general public about the potential of evaporation energy. So the CRE, the proposed CRE efforts will also dramatically enhance our application for federal grant funding opportunities. So currently, fundamental studies on water responsive materials are funded by ONR, Air Force, and Army, as well as Canon. And the team will keep submitting proposals to DoD as well as other agencies, including DOE, NSF, and Sloan Foundation. For example, the team just submitted a proposal to the NSF Convergence Accelerator Program last week. No, 2 weeks ago, I'm sorry. We also expect the emerging field of the high growth science will have a big opportunity in the near future. For example, evaporation is a major power source in nature. Here I show you a picture about a tall tree, California. It's a redwood. This tree can grow up to 100 meters up. It's really tall. And trees use evaporation to lift water from soil to their leaves, which is 100 meters above the ground. Is incredible. And these examples illustrate tons of opportunity for us to mimic nature's functionality to harness evaporation energy for many different applications. So we expect that in about 5 to 10 years, our research will fund applications in other fields and in new technologies. At that point, different funding sources can propel the future progress of the field. That's it. Thank you for your attention, and I'm happy to take any questions.
So thank you, Shi. Can you stop sharing?
Yes.
So Alan says he has a general question. Do you want to chime in as to what your general question is?
That will be Alan with.
No, not you, Alan. Another Alan. Alan, yeah, go ahead, Alan. Not Alan Shi, but Alan. Okay, we're going once.
Oh, I'm sorry. Good afternoon. I thought I was unmuted. I had a question regarding the evaporation model. I was wondering, because it's a general question. So you're harvesting solar energy using evaporation.
Yes.
So the point of it would be so that you would even use it at night when there wouldn't be solar energy to use, from my understanding, or?
Yeah, so you mean basically evaporation, that doesn't matter whether there's sunshine or not. Evaporation happens all of the time, right? So once, because our Earth, that's the beauty of our Earth, and then if we have the liquid phase of water, right? So evaporation always happen. And
okay, thank you.
So another question. the efficiency of harnessing the kinetic energy, is it practical?
Yes, we initially published a paper in Nature Communications, and then in the preliminary study, we estimate the efficiency to be, I mean, the annual, definitely it depends on the weather pattern, depends on where you are. But let's see, in US, the average annual efficiency can reach 15%. Our material efficiency can reach 80%. Does it answer your question?
Yeah, well.
And yeah, it is. Short answer is it is feasible, and but in the is I think it's all about the prices and the life cycle CO2 emission.
Right. So the other question was, you know, there are fluctuations. So the question was about day, night, but sometimes it's more humid, less humid. How do you handle those fluctuations in the weather?
Yeah, this is a system level. How to say? This is really great. This is a great question. In the previous study, actually, in the Nature Material Communication paper, we also basically we can control this kind of power delivery by integrating feedback system. For example, I give you some simple example. Let's see if we do not need the energy, we just stop the engine and cover the water surface, and then actually the energy will be stored in the water as the heat. And whenever you need it, right? So we just let it go. And in this case, actually, water is a battery. And for example, to tolerance this kind of a daily fluctuation of evaporation weather pattern, actually, by controlling the evaporation rate artificially, we can easily, how to say, smooth out this kind of fluctuation.
Mm-hmm. So would this be more feasible to operate in hotter, humid climates?
The hotter, the drier, the better.
The hotter, the drier, the better.
The better. But New York is not that bad. New York, annual power can roughly reach 4 watt per meter square. If we only do one layer, annual power density can be around 2 to 4 watts, because we have a long winter. But they only assume we do one layer. But actually, we can also do multiple layers. We can integrate. It's like we can build solar cell can only do one layer. Our technique, we can make a building like structure. Mm-hmm. And also internet is really depends on whether we want to save the earth or make money. And ideally, we can also force the evaporation.
Okay, a couple more questions. How expensive is this relative to other renewable energy systems?
Our estimation is okay if we control the material price to about $5 per kilogram. We know this. Our current material actually is within the range. The electricity price can be around 2 cents per kilowatt hour if we develop a technique in US. The current solar, I think right now with the tax deductible, I think it's about 10 cents per kilowatt hour, something like this.
Okay.
So the price is lower, and actually the price is even lower than the price the electricity price from the coal power plant.
May I ask another question?
Yes.
Yeah. I was looking at, sorry, Alan, I was looking at Ray. Did you want to add something to this, Raymond, too? No? Okay. Oh, wait, I got one more.
Sure.
So the effect on the environment, is there any negative effect on the environment from this?
Yes, nothing's free. It's very similar to the solar power and the wind power. For example, if we put if we cover the whole water surface on planet, right? So definitely we will change the weather pattern. That's the reason why we do have this kind of system level simulation showing, okay, if we cover, let's see, if we cover a certain amount of water area, right? So what's the impact on the environment? So, Charlie already has the model, right? So to do this kind of analysis, and then this is part of the, how to say, objective 3 in this proposal.
Right. Alan.
Well, actually, he kind of answers my question, because for the solar energies, when you place the solar panels, you are basically fighting for the land with the farming communities and so forth. And also when you are doing the solar, the wind turbines, so there will be pushback from the community for the noise from the wind, from the wind turbines in terms of audio pollution and the visual pollutions. So I was just about to ask a similar question about that. If you want to deploy your system, what kind of a community pushback that you would expect?
So that's another kind of how to say, that's another reason why we want to maybe build how to say, use our technique, build some indoor self-powered purification system to switch the, how to say, to switch some how to say, to target the customer of maybe building managers and residents first, instead of initially go to, how to say, the large scale energy power production business. And first, I'm not saying, our techniques is not good for the large scale regional power production, is because the sense that because to enter the energy market the barrier is really high. We need tons of capital investment to make the pilot power plant. But initially we can start from the small scale and targeting a little bit different customers.
So it's 3 o'clock. It's actually 3:01. So I do want to end on time. There's one other question about hybrid systems. You may want to think about that in terms of incorporating with solar cells, but that's just a suggestion. So what I want to say is thank you for everyone for joining these sessions. If the CRC members, if you have 5 minutes to stay on so that we could just talk about the process from now. And everyone else, thank you for joining. If you have questions about the research that was presented, feel free to reach out to the teams. And we will be in touch by middle of August, end of August, beginning of September is when we plan to make an announcement of the selection. So thank you again, and we'll be in touch.
Araceli, would you mind stop the recording?